Good morning to one and all present here. I am Dr. S. Prema, Associate Professor, Information Technology. Today I am going to discuss the topic is Introduction to Data Structure. So these are the contents. First we are going to see what is data structure and what are the data structures, why are data structures important, and next one we are going to see types of data structures. So first we are going to see what is data structure. A data structure is a way of organizing and storing data in a computer so that we can easily access and modify efficiently. So this is the basic definition of data structure. So this is the general structure, so how we are organizing the data. For example, so here we have to collect the data and also we can represent with the structure of the data. So this is a general structure. Based on this structure we can able to organize the data. So next one, so why are data structures important? The first thing is efficient data management, and also by using this data structure we can able to improve the performance, and also we can able to use the resource optimization process, and also we can define the data relationships, and also we can enhance the algorithm efficiency, and also data structure we can implement with the real-time applications. So by using this data structure we can easily measure the scalability of your process. So these are the major things we must know about the data structures, important things. So this is the types of data structure. So if you are taking data structure means it can be classified into two ways. So one is you call it as linear data structure, then another one you call it as non-linear data structure. So if you are taking linear data structure means, so we can represent array is the example of linear data structure, and stack is the example of linear data structure, and queue is the example of linear data structure, and linked list is the example of linear data structure. If you are taking non-linear data structure means the best example is graph is the example for non-linear data structure, and also tree is the example for non-linear data structure. Next one we are going to see what is linear data structure. The data is stored in a linear structure sequentially. So if you are using linear data structure means here you should follow the sequential order. So if you are choosing the elements means, so that is you have to store in one after the other without applying any mathematical operations. So this is the way of organizing linear data structure. So this is the general structure. So how we are using linear data structure. For example, 0 you consider as the index value. So from this index value we can able to store the element or item. For example, if you are taking A means this is you call it as data element or item. So this is we can store in the array index value 0. So this is the way to organize your data. So if you are using linear data structure means we have to follow the sequential manner. So this is a way to represent the linear data structure. So next one, if you are using linear data structure means you have to use the example of array data structure. If you are using this array structure means, so you have to use the collection of items that is stored in continuous memory locations. So this is the main thing we are using array data structure. So this is the example representation. So here we are assigning the index value 0, 1, 2, 3, 4, 5. You consider like that. From this index value you start to store your data elements. For example, if you are starting the index value is 0 means we can store the data value is 2. For example, if you are considering the index value 1 means we can store the data value 4. So this is the way to organize the array data structure. So if you are using array data structure means we have to use the continuous memory locations. So this is a basic procedure to represent the array data structure. So next one we are going to see what is stack data structure. If you are using stack data structure means we have to follow the principle of LIFO. So this is you call it as last in first out. By using this principle only we can able to implement the stack structure. So by using this LIFO principle we can able to insert the element, and also stack is removed from the first element. So here we are going to execute. So how we are using the concept of LIFO principle. So in this LIFO principle we are using two operations. So one is we call it as push operation, another one we call it as pop operation. So if you are using push operation means it is going to insert the element into the stack. So that is we call it as push. So next one we are going to see what is pop. So if you are using pop means it is going to remove the element from the stack. So by using push and pop we can implement the principle of LIFO. So this is the example representation for LIFO. So first we take empty stack. So in this empty stack we did not include any element. So after that we are going to perform the operation of push. So we start to insert the element 1. After that we start to insert the element 2. So this is you call it as insertion operation. For example, if you want to pop your stack means, so we have to choose the topmost element in the stack. So in last stack we are using 3 values 1, 2, 3. So here 3 is the topmost element of the stack. We start to remove the value 3. After we start to remove the value 2. After we start to remove the value 1. So this is the basic principle we can implement LIFO principle. So next one we are going to see what is queue data structure. So in this queue data structure, so we can use the linear data structure concept. So this is the open-end operations. So here we can implement the principle of first in first out order. So this is the general representation of queue. So first we have to create the queue 1, 2, 3, 4, 5. So these are the queue values. This is kept in the order. So here you have to indicate which one is the front position of the queue and which one is the back position of the queue. So after that we have to perform NQ and DQ operations. So for example, if you are taking NQ means, so here you have to indicate Q first position, front position, and Q last position, you have to indicate last position of the Q. Last position of the Q you call it as end of the Q. So that is you call it as NQ operation. After that if you are using front, so in front means we have to create the queue. So in this queue, which one is the standing in the front position? So that is indicate front position of the queue. After that you have to use delete queue. So in this delete queue, we have to choose the first position of the queue. So in previous structure, we are using the value is 1. So we have to indicate the first value of the queue. So you start to remove it 1, after that you start to remove it 2, after that you start to remove it 3. So this is the delete queue operation execution. So next one we are going to see linked list. So this is also we are using the concept of linear data structures. So here we can't use the continuous memory locations. So by using the pointer only we can able to link the node from one to another. So this is the representation of linked list. By using the node only we can able to store our data. So this is the general structure. So how we are using the concept of linked list. So first we take one node. Within this node we have to use data element and also we have to use pointer field. So if you are representing the node means in that node we have to use the data value and pointer field. So by using the pointer field only we can be able to link the another node of the process. Then last node you are going to indicate the null value. In first node you are going to indicate the header of the linked list. So this is the basic structure. You have to create the linked list. So next one we are going to see what is nonlinear data structure. So in this nonlinear data structure, so here the elements are not arranged in sequentially. So this is the main thing. So we are studying the concept of nonlinear data structure. So this is the general structure. If you are using nonlinear concept means the element is present in any order. So this is the way to organize the nonlinear data structure. So this is the best example of nonlinear data structure. So this is you call it as graph data structure. Graph data structure you call it as nonlinear data structure. So in this graph we can able to use finite number of vertices and edges. By using this edges, we can able to connect the vertices. So this is the example representation. For example, A denote the node of the graph and B denote the node of the graph. You consider like that. So A sometimes you call it as vertices. Then and also in between the vertices we can able to use the edges. So next one we are going to see tree data structure. So if you are using tree data structure means, so here we have to use the hierarchical structure. By using this structure only we can able to represent and organize the data, and also we can able to navigate and search your process. So this is the way to represent tree data structure. So this is the example representation of tree data structure. First we start with root node, and within this root node we have to use the key element of the root. In tree data structure, if you are representing the root node means you have to mention the key value of the root. After that you start to construct the parent node of the tree data structure, and also you have to develop the subtree, and also you have to create the siblings of the tree data structure. So this is the basic representation. You must know about the non-linear data structure operations. At the end of the session, students will be able to know about what is data structure, and also explain the importance of data structure, and also students will be able to know about the types of data structure. So these are the main thing. So we can learn from this introduction to data structure topic. Thank you.